I want you to just mentally transport yourself for a second. Put yourself right in the trunk of a customized 1998 Honda Civic.
Oh, man. Yeah, I know exactly where you're going with this.
Right. You know the exact vibe. We're talking about the undisputed golden era of car audio here.
The heavy metal era of bass.
Exactly. I want you to picture those massive, just imposing slab amplifiers bolted to the back seats.
The ones with the deeply grooved, super aggressive metal heat sinks running down the sides.
Yeah, the ones that look less like consumer electronics and more like aerospace cooling equipment.
You can practically feel the sheer thermal mass of that extruded aluminum just by looking at it.
I mean, the machinery itself was making a statement. You were broadcasting serious industrial heft.
And the sound, too. That concussive resonant bass that vibrates your rib cage before your ears even register the actual frequency.
Totally. So hold that entire sensory image in your head for a second. The heavy metal slab, the Brewless cooling fins, the raw power. Now take that massive 20-pound aluminum heat sink and shrink it down. Keep shrinking it until that entire intimidating amplifier is small enough to sit perfectly inside the palm of your hand.
Which is just crazy to visualize.
It is, but here's the real paradox. Despite being roughly the size of a deck of cards, it still pumps out crystal clear, room-filling Bluetooth audio.
And that instantly creates this jarring cognitive dissonance, you know?
How so?
Well, your brain processes the visual cues of the heavy fins and the aggressive styling, right? So you're expecting substantial physical weight.
Right, your muscles are prepping to lift something heavy.
Exactly. And when you pick it up and realize it only weighs a few ounces, it forces you to reevaluate what you're actually holding.
That visual and tactile paradox is the central subject of our deep dive today. We're looking at a specific creation called the MAD MINI.
A fully functional, miniature 2-channel Bluetooth amplifier.
Built by Jeremy Filler, who operates under the brand MadLabz, or MadLabz with a Z on his channels.
And we're tracing the genesis of this device using a very specific stack of primary sources today.
Yeah, let's lay out the sources for everyone.
So we've been reviewing a series of raw, over-the-shoulder YouTube build logs from the MadLabz channel, plus transcripts of his promotional materials.
And to ground all of this in actual commerce, we're cross-referencing those videos with live eBay listings.
Right. Both the listings for the raw, unbranded electronic componency sources and the active storefront where he actually sells the finished MAD MINI.
So our mission for this deep dive is to basically reverse engineer Jeremy's entire process.
Unpacking how he takes a highly vulnerable, generic electronic module and just wraps it on a pure old school cool.
And we're using the MAD MINI as a lens to examine a much larger shift, because this project is empirical evidence that the barrier to entry for manufacturing from scratch has collapsed.
It really has. Building a physical product doesn't strictly require a massive overseas factory complex anymore.
No, it's happening right now on desktop tables in backyards across the United States.
I mean, if you think about this process mechanically, it shares a lot of DNA with custom hot rod culture.
Oh, that's a great analogy. Because a builder doesn't usually forge their own engine block from raw iron ore. Right?
Exactly. They source a crate engine, and then they engineer a bespoke chassis, the suspension, and the aesthetic shell around it.
Jeremy is operating on that exact same principle, except his engine block is a microchip.
And his garage is a computer desk.
Yeah, and his fabrication plant is driven by stepper motors and extruded 3D printer plastic.
It's wild. But to understand the vehicle, we really have to start by looking at the engine.
Let's get into the beating heart of the MAD MINI. According to our source dive, it's a module designated as the XYP15W.
A dual-channel stereo Bluetooth power amplifier.
I actually pulled up the live eBay listing for this from a vendor operating under the name Easy Life Edge. And the accessibility of this hardware is just staggering.
How cheap are we talking?
You can purchase this raw functional circuit board right now for approximately $17.52.
Wow. Under 20 bucks.
Yeah. And it operates on a pretty wide voltage range, taking anywhere from 12 to 24 volts of direct current.
Looking at the bare XYP15W provides a masterclass in the realities of globalized component manufacturing, honestly.
Because it's so raw.
Exactly. In its raw form, it's purely utilitarian. It's just a green fiberglass printed circuit board.
Densely populated with surface mount capacitors and a Class D amplifier chip.
And those exposed screw-down terminal blocks for the speaker wire? I mean, it is a miracle of modern supply chains, but it is completely naked.
Right. Without an enclosure, it's highly susceptible to static discharge, physical stress.
Environmental damage, yeah.
Yeah.
A stray drop of condensation or like a drop screwdriver will short the traces and destroy the board instantly.
So it's an ingredient. It's not a meal.
That's a perfect way to put it.
And you see millions of these boards flooding e-commerce platforms,
Yeah.
usually accompanied by some highly questionable marketing copy.
Oh, the inflated specs are hilarious.
Yeah, the listings for these XY-P15w modules claim they can push 30 watts, 40 watts, or even up to 150 watts of quote-unquote digital high power.
Depending on the input voltage, supposedly.
Right. But Jeremy addresses this immediately in his build log. And his transparency is actually super refreshing.
He doesn't buy into the hype at all.
Not for a second. He looks at the board, points to the tiny amplification chip, and gives his audience a blunt reality check about the physics of audio power.
Because he strips away the marketing fiction. The physics of amplification dictate that generating audio power simultaneously generates thermal energy.
Heat. Lots of heat.
Exactly. The manufacturer might be quoting an absolute peak wattage, right? Like a momentary spike the chip can handle for a microsecond before catastrophic failure.
But Jeremy knows that sustained, continuous power, what we call RMS wattage, tells the real story.
Yeah, he points out that without a substantial physical aluminum heatsink bonded directly to that silicon chip to pull the heat away,
There is absolutely no way that board is pushing 40 sustained watts.
the silicon would just reach its thermal limit. It would either engage its onboard protection circuit and shut the audio off entirely, or
Literally melt the internal junctions.
it would cook itself.
So he correctly identifies it as a solid, reliable 15-watt per channel board,
Wow.
which is plenty of volume for his specific use case.
But he flat out refuses to pass those inflated 150-watt claims onto his own potential buyers.
Which speaks to his integrity as a builder.
Mm-hmm.
But, looking at this workflow, buying a $17 pre-assembled board from an overseas vendor and designing a plastic shell for it.
It brings up that semantic debate, right?
Yeah, the one that constantly surrounds modern maker culture.
Yeah.
Is Jeremy actually, quote-unquote, manufacturing a product from scratch, or is he just acting as middleman, repackaging someone else's tech?
We really have to completely update our definition of manufacturing for the 21st century.
How so?
Consider the automotive industry. A major manufacturer like Ford or Toyota does not mine their own iron ore.
Fair point.
They often don't manufacture their own airbags, and they frequently source their transmissions from specialized external companies like ZF or ASIN.
They purchase those highly complex subassemblies and integrate them.
Exactly. They engineer the user interface and build the safety and aesthetic structures around them. But no one argues that Ford isn't a manufacturer.
Right, and the consumer tech sector operates on that exact same logic. Apple doesn't fabricate the silicon wafers for their processors.
They source raw OLED panels from Samsung or LG.
And they buy camera sensors from Sony.
Because integration and contextual design are the fundamental pillars of modern manufacturing.
So Jeremy, taking this fragile circuit board that a normal consumer couldn't safely use,
And engineering a completely new, resilient ecosystem for it, that is manufacturing.
he's defining its user interface, giving it environmental protection, and assigning it a specific cultural identity.
Transforming a raw component into a finished, user-ready consumer good is the literal definition of manufacturing.
The value is entirely in the execution.
So let's look at how he actually executes that transformation.
Yeah, moving from a naked green circuit board to the rugged MAD Mini requires a deep dive into Jeremy's prototyping process.
In his videos, he takes his viewers directly into his computer-aided design, his CAD software, to demonstrate the structural engineering.
And the timeline he reveals is fascinating.
Yeah.
He notes that mocking up the initial digital skeleton of the amplifier took him roughly an hour and a half.
The basic geometric concept came quickly, but translating that digital concept into a viable physical object that required at least 6 distinct printed revisions.
6 revisions. That really highlights the incredible leverage that desktop manufacturing provides today.
Oh, absolutely. Think about trying to design a custom plastic enclosure for an electronic device even 15 years ago.
The barriers were nearly insurmountable for an individual.
You'd have to draft the design, send the CAD files to a tooling facility, and pay tens of thousands of dollars just to have a machinist cut a reverse image of your part into a block of hardened steel.
For an injection mold,
Yeah.
right. And then you wait weeks for the prototype.
Yeah. And imagine if you realized the mounting holes for your circuit board were misaligned by like a single millimeter.
That expensive steel mold is suddenly completely useless.
You had to start over and pay for new tooling. The financial risk of a single mistake effectively locked individual inventors out of the hardware market.
But Jeremy is utilizing fused deposition modeling, or FDM 3D printing.
Specifically, he relies on a machine called the Creality K1SE.
And he spends a significant portion of his log praising the automation of this specific printer, particularly its auto bed leveling and self-calibration routines.
The evolution of those leveling systems has completely changed the workflow.
I remember the early days of desktop 3D printing. Calibrating the machine was a highly manual, intensely frustrating process.
Oh, the paper trick.
Yes. You had to slide a piece of standard printer paper under the blazing hot nozzle and meticulously adjust 4 tiny thumb wheels under the print bed.
Until the friction on the paper felt exactly right across the entire surface.
And if the bed was tilted by a fraction of a degree, your print would detach and fail hours later, just spaghetti everywhere.
But modern machines like the K1SE use load cells or induction probes to physically map the topography of the print surface before every single job.
So the machine creates a digital mesh of the bed's microscopic imperfections.
And it dynamically adjusts the height of the print nozzle on the fly to compensate.
By removing the mechanical frustration of maintaining the machine, the creator's cognitive load is completely freed up.
Exactly. They can focus purely on the engineering of the product.
And Jeremy's engineering is highly precise. He isn't just eyeballing the dimensions of this enclosure.
No, he relies heavily on digital calipers.
He points out that despite only costing him a few dollars, they allow him to measure the physical XY-P15w circuit board down to fractions of a millimeter.
He actually mentions a very specific tolerance in the video. He measures the board so he can design the casing to hold it exactly at 0.80 millimeters to center.
Wow, 0.80 millimeters. Why is that specific tolerance so critical?
Well, it's the difference between a prototype that survives shipping and one that shatters the first time it's used.
Because of mechanical stress.
Right. When you mount a printed circuit board inside a rigid plastic enclosure, if the plastic standoffs beneath the board are uneven, or if the mounting holes don't perfectly align.
Driving a steel screw through the board creates a fulcrum.
Exactly. You're forcing a flat, rigid fiberglass board to bend to accommodate the imperfect plastic casing beneath it.
And fiberglass does not like to bend.
Not at all. When you torque that board down, the tension pulls at the microscopic solder joints, holding all those surface mount components in place.
Oh, I see. So over time, combined with the thermal expansion of the board heating up and cooling down,
Or even just the physical vibration of the speaker it's powering.
those strained solder joints will crack.
The audio will start cutting out, or the board will just fail entirely.
But Jeremy identified this tension issue immediately.
Yeah, instead of just creating simple mounting posts, he completely redesigned the interior geometry of the MAD MINI.
What did he do?
He modeled a perfectly coped, recessed shelf deep inside the casing, so the board rests flush against a solid perimeter foundation.
Meaning the casing physically supports the board uniformly.
Right. The screws simply hold it in place without forcing the board to warp or conform to the plastic.
That is a highly sophisticated approach to mechanical longevity.
And you can actually watch his problem-solving process happen in real time as the printer runs in his videos.
Oh yeah, there's that specific moment in his build log where he's observing the machine lay down the first few layers of an early prototype.
And he notices a mechanical artifact in the print itself.
He realizes that whenever the print nozzle encounters a sharp 90-degree internal corner in the casing design, the machine vibrates.
He refers to it as a jiggle.
A jiggle, right, which is actually a well-documented physics problem in FDM manufacturing, isn't it?
Yeah, it's known as ringing or ghosting.
How does that happen?
Well, the print head on these machines has physical mass, and it's being driven by rubber belts and stepper motors at very high speeds.
Like 150 millimeters per second.
Exactly. So when the machine is instructed to travel that fast and suddenly hits a hard 90-degree angle, the mass of that print head wants to keep moving in its original direction.
Because of inertia.
Right. So the motors have to apply a massive amount of instantaneous counterforce to stop the tool head and violently pivot into the new vector.
And that sudden transfer of kinetic energy sends a resonant vibration through the entire frame of the printer.
Which then translates into the extruded plastic as a rippled, messy texture right at the corner.
So how does he fix a mechanical vibration issue on the physical assembly line?
He alters the digital geometry of the product.
He goes back into his CAD environment, right?
Yeah, he selects all of those sharp internal 90-degree corners and applies a command called a fillet.
By adding a 1 millimeter radius curve to those harsh angles, he fundamentally changes the G-code the instructions sent to the printer.
Exactly. Instead of hitting a brick wall and turning, the printer head now smoothly interpolates through the curve.
It maintains its velocity vector without the violent inertial shock.
The vibration is eliminated, and the surface finish of the plastic improves dramatically.
And Jeremy knows that it actually marginally reduces material usage and print time, too.
Because the machine doesn't have to decelerate, extrude plastic deep into a sharp point, and then accelerate out of it.
It's an elegant optimization loop. He designs digitally, tests physically, observes mechanical inefficiencies, and refines the digital code.
But engineering a mechanically sound, vibration-free enclosure is really only the foundational layer of product design.
Right, because a robust plastic box that safely houses a Bluetooth board is ultimately just a utility object.
What transforms the MAD Mini from a functional container into a highly desirable consumer product is its visual language.
Which brings us to the aesthetic design, the pursuit of old-school cool.
We established earlier that the XY-P15w doesn't generate enough heat to require massive thermal dissipation.
So why does Jeremy spend hours in CAD meticulously modeling deep, aggressive cooling fins onto the side of this tiny plastic box?
Because he understands the semiotics of industrial design.
We don't evaluate objects purely on their functional utility.
Exactly. We evaluate them based on the emotional and psychological triggers they activate.
And Jeremy deliberately styled the MAD Mini to mimic the iconic slab amps of the late 90s and early 2000s car audio scene.
The attention to detail on those fins is striking. He doesn't just slap a generic corrugated texture onto the side.
No, he walks the viewer through his digital model, highlighting the specific dimensional rhythm he programmed into the profile.
The fins actually step upward in thickness.
Yeah, starting at a 2mm extrusion at the bottom, stepping up to a 3mm fin, peaking at a 4mm fin in the center, and then stepping back down symmetrically to 3 and 2mm.
That stepped profile directly mimics the way large-scale aluminum heat sinks are extruded in industrial foundries to maximize surface area.
So by replicating that specific geometric pattern in 3D printed plastic, he's hacking the viewer's visual expectations.
He's signaling power, durability, and premium audio fidelity before the device is even turned on.
But I think the most clever aesthetic feature is the clear viewing window on the top of the unit.
Oh, absolutely. He wants the user to be able to look inside and actually see the surface mount components.
And the glowing blue power LED of the raw circuit board.
But the way he engineers the assembly of that window is brilliant. It's a perfect example of design for assembly, or DFA.
Because in traditional manufacturing, every additional screw, every extra minute spent assembling a unit
Destroys profit margins.
Right. Jeremy wants a clear window, but he doesn't want to deal with microscopic fasteners to hold it in place.
So he designs a tiny, precise ridge and an open slot directly into the 3D model of the casing.
Once the plastic shell is printed, he can simply take a custom-cut piece of clear plexiglass, slide it smoothly into the friction-fit slot, and secure the entire assembly with a single microscopic dab of adhesive at the very end.
It completely eliminates mechanical fasteners and streamlines his local production process.
It's highly efficient, but again, its primary purpose is experiential.
Exposing the internal circuitry through that window, combined with the aggressive fins and the functional screw-down terminal blocks on the exterior, creates a distinct narrative.
And when Jeremy shows off the final first edition unit, which he meticulously hand-painted in a vibrant color, he calls Tuscan teal.
He does something very specific to drive home the physical reality of the object.
He places a standard, ubiquitous plastic pocket lighter directly next to the finished amplifier on his desk.
And the scale is almost comical.
The entire amplifier is barely larger than the lighter. It completely shatters the illusion created by the aggressive styling.
But it makes you ask a question.
Yeah, if the fins are purely decorative and the device is entirely plastic, isn't it ultimately a superficial waste of material?
Not if you understand the psychology of perceived value.
Because human beings are deeply tactile creatures.
We have an ingrained heuristic that equates physical mass and density with quality and power.
A lightweight object feels cheap, hollow, and disposable.
While a heavy object feels engineered, premium, and durable.
And Jeremy actually acknowledges this psychological quirk directly in his video.
While holding the empty, lightweight plastic shell, he jokes that he is tempted to glue a solid lead ingot inside the casing before he seals the circuit board in.
He says he wants people to pick it up and instantly say, "Oh, dude,"
No.
because the unexpected heft implies high-end internals.
That joke demonstrates a profound grasp of product design. He knows that the form factor communicates a promise to the user.
The aesthetic weight of the design compensates for the lack of actual physical weight.
He isn't just selling an audio circuit. He's selling the nostalgic experience of vintage car audio culture distilled into a desktop format.
So who exactly is buying a miniaturized homage to vintage car audio?
This brings us to the deployment of the MAD MINI out in the real world.
Initially, Jeremy targets a very specific, highly dedicated subculture. In his promotional videos, he speaks directly to the remote control, or RC, community.
And it is crucial to understand the modern RC hobbyist landscape here.
Yeah, this is not the demographic of children driving plastic toys around a cul-de-sac.
Not at all. This is a community deeply invested in what they call scale realism.
They build intricate, highly customized remote control vehicles, often rock crawlers or scaled trucks, that are engineered to mimic full-size vehicles down to the microscopic details.
They'll weather the paint to look like actual rust, fabricate tiny canvas-scale tents for the roof racks, and install functioning miniature winches on the bumpers.
But Jeremy noticed a massive aesthetic disconnect when it came to audio.
If an RC builder wants their customized scale truck to actually play music while they drive it, their only real option has traditionally been to strap a generic, modern, cylindrical Bluetooth speaker into the flatbed,
Which instantly destroys the illusion of scale realism.
You have a meticulously crafted miniature 1980s Toyota pickup truck, and sitting in the back is a pill-shaped piece of modern consumer electronics.
The MAD MINI was engineered to bridge that exact aesthetic gap.
Jeremy explicitly markets it to what he calls RC addicts tired of the tiny audio on the ground.
Because the MAD MINI looks like a real aftermarket car amplifier, it can be mounted directly into the chassis or the trunk of a scale RC vehicle and look like it absolutely belongs there.
He even suggests pairing the MAD MINI with scale 3D printed subwoofers.
Yeah, specifically mentioning his own RC2 Rampage series enclosures.
He's providing the infrastructure for these hobbyists to build complete, visually accurate, functional scale audio systems.
He talks about giving them the ability to have the loudest rig in the whole graveyard.
The graveyard being the dirt tracks, the abandoned lots, the crawling courses where these communities meet up to drive.
It's a brilliant, hyper-focused niche. But the true genius of the MAD MINI is that it refuses to stay confined to that niche.
As we see in his final reveal videos, the scope of the project naturally expands beyond the RC dirt tracks.
Jeremy clearly states that the underlying XYP15W module and the finished MAD MINI itself are not restricted to remote control applications.
By committing so thoroughly to the high-quality, old-school, cool aesthetic, he inadvertently engineered a crossover product.
It's like a Swiss Army knife for audio. A product born from the muddy, high-impact world of RC rock crawling is suddenly elegant enough to serve entirely different use cases.
He points out that you can wire it up as an incredibly unique, portable, old-school stereo for sitting on your back porch.
Or you can set it up as a conversation-starting mini stereo system for a bookshelf inside your house.
This phenomenon occurs frequently in grassroots manufacturing.
When a creator attempts to solve a highly specific problem for a deeply niche community.
Exactly. In this case, scale audio realism for RC crawlers. They often strip away all the generic, uninspired design elements found in mass-market products.
The resulting object is so unique and visually arresting that it attracts a universal audience.
People who have never touched an RC car in their life see the MAD MINI and want it simply because it's a fascinating, tactile piece of desktop architecture.
It has universal gadget appeal. And that transition from a niche hobby project to a universally appealing product leads us to the final and most crucial layer of our analysis.
We've examined the raw components, the thermal physics, the CAD geometry, and the psychology of the design.
Now we must examine the economics. How does an individual operating out of a spare room or a garage turn this into a viable commercial enterprise?
We're looking at the financial mechanics of micromanufacturing here. The live eBay listings provide the exact margins of this operation.
Let's break down the ledger for everyone listening. Jeremy lists the completed, one-of-a-kind Tuscan teal first edition MAD MINI on his MadLabz eBay storefront.
The purchase price is $49.99.
Now compare that to our initial data point from earlier.
The raw, functional XYP15w circuit board cost him exactly $17.52.
Meaning he has generated roughly $32 of pure value through his localized engineering.
He took a $17 component, added a few dollars worth of 3D printer filament and acrylic, and created a $50 consumer product.
That $32 margin is the direct monetization of design and integration.
And he's completely transparent about his production roadmap in the listing. He notes that this specific unit is a one of one, carrying a premium for being the hand-painted first edition.
But he explicitly outlines his plan to reduce the retail price once his local production line is fully optimized.
And he begins, quote, mass-producing these little puppies.
The phrase mass-producing is the operative concept here because it highlights how completely the traditional rules of industry have been rewritten.
For the entirety of the 20th century, the concept of a single individual mass-producing a physical consumer electronic device was a mathematical impossibility.
Because of the minimum order quantity, right? The MOQ.
Exactly. If you wanted to manufacture a custom plastic shell for an amplifier in 1995, you had to contract a factory in a manufacturing hub like Shenzhen.
Because the factory had to spend tens of thousands of dollars machining the steel molds for your specific part.
They would not power up their injection molding machines unless you guaranteed an order of 10,000 or 50,000 units.
You had to have massive venture capital funding just to get the factory on the phone.
The MOQ killed millions of independent ideas before they ever left the sketchpad.
Even in the modern era of crowdfunding, we see Kickstarter projects constantly collapse because they underestimate the massive upfront capital required for overseas tooling.
But Jeremy has entirely circumvented the MOQ.
He bypassed the overseas tooling facilities, the shipping container logistics, and the supply chain delays.
His Creality K1SE 3D printer is his injection molding machine.
His CAD software is his engineering department.
And his spool of PLA filament is his raw material supply.
By leveraging decentralized digital manufacturing tools, the minimum order quantity for the MAD MINI is exactly 1.
He can spin up a production run of a single unit, test the market on eBay, and if it sells, he simply presses print again.
It is zero-risk manufacturing.
And he is highly aware of the brand equity this local artisanal approach creates.
He closes his promotional videos with a very specific tagline: MadLabz resale, except no substitutes.
That phrase is a declaration of value. When a consumer purchases a MAD MINI, they are not buying a faceless, mass-produced commodity from a big-box retailer.
They're participating in a narrative.
They know exactly who engineered the casing. They can watch the YouTube video of him identifying the jiggle in the print and adding the fillet to fix it.
They know the exact origin of the object sitting on their desk.
It's farm-to-table economics applied to consumer electronics.
A massive, multinational corporation churning out millions of generic Bluetooth cylinders cannot synthetically replicate that level of authenticity.
Or that intimate connection between the creator and the consumer.
The MadLabz project serves as empirical proof for the broader DIY community that the infrastructure for local manufacturing already exists.
It demonstrates that combining readily available raw components with desktop fabrication tools and strong industrial design can yield a commercially viable product.
Without ever leaving your backyard.
It really is incredible.
Let's pull all of these threads together. We began this journey looking at a $17 mass-produced, highly vulnerable green circuit board covered in surface mount capacitors.
We tracked how Jeremy Filler analyzed its thermal limits, rejected the marketing hype, and engineered a protective ecosystem around it.
We explored the physics of 3D printer calibration, the elimination of mechanical resonance through digital fillets,
and the critical importance of measuring to the half millimeter to prevent circuit board tension.
We then analyzed how he leveraged the semiotics of vintage car audio, the stair-stepped cooling fins, the clear display window, the Tuscan teal paint,
to hack the psychology of perceived weight and value.
He created a device that seamlessly bridges the hyper-niche world of scale RC, rock crawling with the universal appeal of a conversation-starting bookshelf stereo.
Ultimately, the MAD MINI is a masterclass in modern making.
It proves that the era of relying exclusively on massive, distant industrial complexes to build our ideas is over.
The capability to manufacture premium, highly customized physical goods is currently sitting on desktop tables around the world.
But if we extrapolate the trajectory of this localized manufacturing model, it forces us to consider a radical shift in how global commerce might operate in the near future.
As machines like the Creality K1SE become faster, more precise, and capable of printing complex multi-material geometries,
the necessity of shipping physical plastic objects across oceans begins to diminish.
Which points toward a completely decentralized supply chain.
Precisely.
We are approaching a threshold where the concept of buying a finished physical product might become obsolete for certain categories of goods.
Think about it. Instead of paying Jeremy $50 for a physical MAD MINI and waiting for the postal service to deliver it,
The future of commerce might be entirely digital.
You would simply purchase the intellectual property.
You pay MadLabz for the genius of the CAD design, the 6 hours of prototyping, and the precise G-code optimizations.
He emails you the digital blueprint, and your own desktop factory fabricates the physical object on demand right in your living room.
The creator ceases to be a manufacturer and becomes purely an architect of ideas, licensing out the ability to print their concepts.
The global supply chain for consumer plastics would be replaced by local material extruders and a marketplace of digital files.
The technological foundation for that reality has already been laid by creators like Jeremy. It's simply a matter of the consumer market catching up to the capability of the tools.
That is an incredible paradigm shift to consider. We are shifting from a culture of mass consumption to a culture of mass, localized production.
It's an exciting time to be a creator.
And with that look into the decentralized future of hardware, we are going to wrap up our analysis for today.
It's been a fun one.
To everyone listening, thank you for joining us as we explore the engineering, the economics, and the old-school aesthetics of the MadLabz garage.
We hope the journey of the MAD Mini inspires you to look at the raw materials and the tools around you in a slightly different light.
Keep questioning how the objects in your life are made. Keep exploring the capabilities of desktop fabrication. And as always, stay curious until the next deep dive.